Hi, I'm Emily from Siemens Digital Industries Software, and today we're looking at enhancements for the 2023 release of NX. Our continuous release cycle means we're always adding new features that benefit you and really enable you to improve your workflows. In this video, we're going to take a look at Design Space Explorer. When we focus on design simulation and analysis capabilities within NX, what we're really talking about is a range of tools. Each of these tools work effectively with one another to enable the recreation of a product's digital twin. These tools include Performance Predictor, Sustainability Impact Analysis, Topology Optimization, and Design Space Explorer. Design Space Explorer searches for and identifies efficiencies by exploring design spaces faster than traditional tools and processes. By using artificial intelligence, it's now possible to deliver a higher quality product with a greater level of refinement. What this means is that engineers have the unique ability to use design, simulation, and manufacturing capabilities in a holistic manner. This approach takes away the need to manually test materials and variables for each design iteration. With Design Space Explorer, we can compare different variations in one go. The result? Newly discovered design concepts, an improved product performance, and optimization processes accelerated by up to 90%. And this shift-left approach to design and simulation is what enables products to get to market faster. We'll use Design Space Explorer and focus on this coffee machine, specifically on the tamping system. The tamper directs water through ground coffee at high pressure, which in turn creates the espresso. Once done, the mechanism discards the used coffee. At this stage, we've used Performance Predictor to validate material choices and evaluate the mechanical performance of the swinging mechanism. Design Space Explorer will take this one step further and automate optimization processes for multiple design iterations of the tamping system. We'll explore the design space by implementing a range of variables and constraints to create the optimal study. Two key goals here are to find the ideal material to use for manufacturing the part and to minimize its total mass. Let's get started. Since we've already used Performance Predictor, we can now set up the Design Space Explorer study to evaluate our options. We can reuse the active analysis at this point so that we're able to optimize the analysis body. Let's go ahead and create our design variable. The power and flexibility of Design Space Explorer means we can set variables on the different feature expressions that make up the tamping system. We can go ahead and set either a discrete variable or a continuous variable. When using a discrete variable, we're setting specific values. It's a good approach to take when aiming for exact figures as part of the study. Using a continuous variable is important when we want to explore a range of values within a series. Setting the increment amount enables us to control the number of changes to run for a specific design parameter. So, let's go ahead and set these variables for different feature expressions on the tamping system. We also want to take a multi-dimensional approach to our study and see how different material variables will perform. It's important to evaluate our options at this point, so we can see the feasibility of each material before the part is sent off for manufacturing. After adding material options to our study, we're now ready to set up our design constraints. A limiting factor of our study is to ensure we keep the amount of stress exerted on the tamping system to a minimum. If the amount of stress exerted is too high, the part will ultimately fail. So, let's set the value for our design constraint to eliminate potential part failure occurring. Additionally, one of our primary goals with the design space study is to reduce the raw materials used and keep the tamping system's total mass to a minimum. The goal here is to satisfy sustainability targets, and this is where setting the design objective comes into play. Once we've done this, we're now ready to run the analysis for our study. This is where Design Space Explorer excels. The study performs multiple design iterations automatically and simultaneously. It's a convenient approach which reduces the need to use traditional tools and processes to achieve the same outcome. As you can see here, NX applies a range of variables and constraints and cycles through these design options by using intelligent search strategies. NX also employs these strategies concurrently, whilst adapting to the problem and learning about the design space. These adaptive optimization algorithms tune into the design space, eliminating the manual need for variable screening, model simplification, space sampling, surface fitting, search strategy selection, and algorithm tuning. See this in action when we run the analysis for the study, and how changes occur to the part as it progresses. These intelligent search strategies are doing a lot of the heavy lifting when optimizing the design space, laying the groundwork to take products to market in a fraction of the time. We're now ready to look at the results of our design space study. The results of each iteration for our design can be seen in this table, with their feasibility visualized with a red, white, and green color system. The goal here is to make it as easy as possible for designers to see which iteration is the best option. For this design space study, we've generated 10 iterations. We can see which have failed and which are suitable but suboptimal. The iteration highlighted in green has optimal design variables, doesn't exceed the design constraint, and satisfies the original design objective. It's a clear design option, so we'll apply that design to our part. And with that, the design space study is now finished. Design Space Explorer enables anyone to conduct optimal simulation studies within NX. These features are all available through value-based licensing, an extension of existing NX software packages. It's an approach that enables cost-effective flexibility so that engineering teams can tap into a vast array of add-ons and tools on demand. Users can access Design Space Explorer from an existing token pool. Alternatively, if you wish to start using value-based licensing, speak to our Siemens account team to get started. What's more, if you're interested in seeing other features we've added to this release of NX, take a look at our June 2023 premiere video by clicking the link in the description. We'll see you in the next one.